Hi there, my name is Matthew and welcome to the third episode of the Ringing Rabbit Hole. In the last episode we discussed calls and compositions, but today I want to talk about place notation, a compact way of storing methods. This is all of plain bob doubles. To share this method with someone else in this form would require communicating quite a lot of data, so let's think of ways to compress it down. We found out in the first episode that the movement of the bells in each lead is the same, so to recreate the whole method we only need to share the first lead. There isn't much point in sending bell numbers here as we are only interested in how the bells move. To store the way these arbitrary bells move, we can split this grid view into each of the changes and then encode all of them individually. Looking at each change, notice how they are made up of crosses and lines. Each line represents a bell making a place, and if a bell isn't making a place, it is swapping places with some adjacent bell. An intuitive way to store a change is thus to store in which positions places are made. For example, this change will be stored as 1, 2, 5. We can apply this encoding to every change in the first lead and can calculate them to get a much more efficient representation of the method. Notice that for changes on an odd number of bells, there is no way to have no places. However, on an even number of bells, you can. To show that no bells make places, we could use this notation. However, we instead use an X to represent a cross change where all bells move. Notice how the full stops around the crosses are inferred, as the X represents an entire change. Something I haven't talked about yet is symmetry. This is the topic I will cover further in a future video, but in short, many methods have some form of palindromic symmetry. This means that if we look at a singular lead, ignoring the next lead head, we can read the grid backwards and still get the same lead. This means that we only need to store one half of this lead and then flip it to get the rest. In terms of changes, if we have a palindromic sequence of changes such as these, we only need to store up to the middle change, as the rest can be inferred from the first half. This gives us another trick to compress our notation. We only need to store half of palindromic sections of changes. We use a comma to show that both sides of the comma are palindromic and should be expanded. Since the right side of the comma only has a single change, it does not require expansion. We can use the same trick to simplify the notation for plain bob doubles. A minor point is that notation by itself isn't enough to uniquely define a method. For example, this notation could generate any of these methods, so you also need to specify the stage alongside the notation. Notice also that if we have a bell making seconds place, we always have a bell making first place, as there is nowhere else for that bell to go, so it is possible to let the first place be implied and only write 2-5 for this notation. This trick also works at the back. Places at the front and back are known as external places, and if a piece of notation contains both external and internal places, it is possible to only keep the internal places in the notation, and have the external places be inferred. For example, if we have the notation 2 for this change, we know that there are no other internal places, so we have a cross here, and the two external bells can't go anywhere, so we have two external places. Internal places can also be implied, however this is less common. If in doubt, just include all the places to avoid ambiguity, and in fact, in most representations of plain bob doubles, 1, 2, 5 is used for this change instead of just 2, even though they are equivalent. Also note that if we have an even stage change consisting of only external places, this could be abbreviated to just one of the places. Describing calls is simple with this notation. When a call occurs, it overrides a small amount of place notation at the end of the lead. The amount of notation and the position where these changes occur vary from method to method, but most of the time it is one piece of notation changed at the lead end. For plain bob doubles, a bob changes the 1, 2, 5 change to a 1, 4, 5 change, and a single changes it to a 1, 2, 3 change. Place notation can also be expanded to work with jump changes, however that is beyond the scope of this video. I have put a link in the description to more information if you are interested. The type of notation used in this video is very common, however there are quite a few variations. One example is microserial, which uses dashes instead of X's, includes the lead encode at the start and uses an ampersand to represent the start of a symmetric section, and a plus to represent the start of a non-symmetric section, with sections separated by commas or spaces. The lead head code is just a way of classifying the lead head of the second lead. That's all I wanted to cover in this video. I hope it was interesting. In the next one I plan to look at coursing order. If you found this video useful, please do share it with others and check out my app Campana for more ringing fun. Have a lovely day.